You're tuned into All This Math. This is Professor Parker. And for today's lesson, we're going to factor a quadratic trinomial. You see this quadratic trinomial I have written here? It says 12x squared plus 5x minus 2. But in the spirit of Kwanzaa and the Nguzo Saba, and day number 2 of Kwanzaa, which is Kujichagulia, which means self-determination in the Kiswahili language, right? We're gonna put a different twist on this. We're gonna utilize a method that I like to call the MalcolmX Method, right? Which is probably why I have this MalcolmX t-shirt on at the same time while I'm recording this video. And this is actually one of my favorite t-shirts, not only because it has Malcolm X on it, and because Malcolm X is one of my favorite, intellectual heroes, but it's also the t-shirt that I had on the day that my youngest son, Kwame, was born 2 years ago. Kwame, who incidentally is named after another one of my revolutionary intellectual heroes, Kwame Ture. So today we're going to talk about the MalcolmX method of factoring quadratic trinomials. All right. So, and the thing about this is, if you go into another YouTube channel, or if you talk to some math teachers, the method that I'm about to get into, they'll probably give it a different name. They'll probably call it the diamond method. But when I look at this method, you end up drawing an X on a piece of paper anyway. So why not evoke one of our ancestors and call it the MalcolmX method? Why not? I mean, if the Greeks and the Europeans can decide to call a squared plus b squared equals c squared the Pythagorean theorem, what's stopping us? So let's get into the MalcolmX method. So first thing we want to do is we want to look at the problem, or look at the expression. And as I said, we have 12x squared plus 5x minus 2. Now our job is to break this down into two binomials. That's the end goal. The end goal is to break this trinomial down, which has 3 terms, 1, 2, 3, into two binomials, right? So this is a step-by-step process. It's an algorithm, and it's going to take some practice. You're going to have to do a bunch of problems over and over again until you get the hang of it. And that's fine. Just about all the math is like that. Most of math, you won't be able to do a problem one time and just get it. And that's cool, right? You got to enjoy the process of getting to the stage where you're proficient. So first thing we want to do is we want to draw X. I'm going to draw X right here. And this is why basically I got the idea to call this the MalcolmX method, right? Now you want to put your AC term right here and your B term right there. Now let me explain this to you. What is AC? What is that? Where does that even come from? Well, this expression is written in the standard form of a quadratic. AX squared plus BX plus C. So that means that this coefficient 12 represents A. This coefficient 5 represents B. This constant, this is not a coefficient, it's a constant, unless you think of it as negative 2x to the 0 power, but that's another story for another time. Let's just think of it as a constant. This negative 2 is C, all right? So AC means A times C. So our first step is actually, or I should say our next step is going to be to multiply this 12 by this negative 2. So we're going to say AC equals 12 times negative 2, and 12 times negative 2 is negative 24, right? And we just identify B. B is just the coefficient of the linear term being 5x. So B is 5. All right. So all I did was I multiplied the first number in the front by the last number in the expression, 12 times negative 2, and I got negative 24. That's going to be important. And then I identified my B term, which is 5. That's going to be important. So I'm going to put those into the X. I'm going to put the negative 24 up here, and I'm going to put the positive 5 right here. Now our next job is to do this. We got to figure out two numbers, right? Two numbers that are factors of this negative 24, and at the same time, those same two numbers add up to positive 5. See, this is when math starts to be like a puzzle. It starts to be like a little more fun, right? Because this is just a game. We're trying to figure out, like, it's almost like playing the game 24, right? If any of y'all like playing that. So what factors of negative 24 add up to 5? Now, if you don't know off the top of your head, that's cool. What you should do is this. On a piece of paper, you should just start listing out factors. List out factors of 24. Actually, negative 24. So let's say negative 24 times 1, right? And then you ask yourself, do those two numbers add up to positive 5? No, they don't. Cross them off the list. What are two other factors of negative 24? What about negative 12 times 2? Do those add up to 5? Nope. Cross those off the list. So right now we're using a method called trial and error, right? We're just going through all of the factors of negative 24 until we reach a pair of numbers that in fact are factors of negative 24 that also add up to positive 5. So the next, what if I did negative 6 and 4? Ask yourself this, does negative 6 plus 4 add up to positive 5? No, it doesn't. Negative 6 plus 4 adds up to negative 2. So that pair don't work. What about negative 8 and positive 3? Negative 8 and positive 3 adds up to negative 5. But I need a positive 5 though. Listen, check this out. Whenever that happens, whenever you get the right number with the wrong sign, that's a good thing. That means you're on the right track. All you got to do is switch the signs around. So that means that instead of a negative 8 and a positive 3, you need a positive 8 and a negative 3. So those are your two, what I like to call your magic numbers, right? Those are going to be your two magic numbers in this MalcolmX method. All right. Now, this is what we're going to use these two magic numbers for. What we want to do is we want to take that trinomial that we started out with, and we want to stretch it out, basically. We want to stretch it out. Like after you wash your clothes, you put them in the dryer, your t-shirt comes out, it's a little bit shrunk up, and it don't fit right, so you got to stretch it out a little bit so you can fit into it the right way. That's what we want to do with this trinomial, right? So this is how we're going to stretch it out. This 5x is going to change. This 5x is going to get stretched out into positive 8x and negative 3x. Positive 8x and negative 3x. And now I'm going to have a 4-term polynomial, right? So the 12x squared is going to stay the same. But the 5x is going to change into 8x and negative 3x. Actually, you put the x's on here, right here if you want to. So 12x squared plus 8x minus 3x, and then the minus 2 is still there. So keep this in mind. That 12x squared stays the same. That minus 2 stays the same. The 5x gets stretched out. And because the 5x gets stretched out, the whole trinomial gets stretched out. So now it went from 3 terms to 4 terms. It went from 3 to 4. 3 terms to 4 terms. Now I got 4 terms. 1, 2, 3, 4. And it's an equivalent expression. It's an equivalent expression. So mathematically, even though it looks different, it has the same value. It's kind of like when you reduce a fraction. The numerator and the denominator are different numbers, but that fraction has the same value. All right? And we can do that. We do that a lot with a lot of things we do in math. All right? So now, back to another connection to Malcolm X, right? And this also ties into something I call hystematics, which I'll talk about more at another time. All right? We're going to create two groups, similar to how Malcolm created 2 organizations near the end of his life. Let's call this first group 12x squared plus 8x. Let's call that the Organization of Afro-American Unity, or the OAAU. And the second group, plus negative 3x minus 2, we'll call that the Muslim Mosque Incorporated. So these are the 2 groups that you're going to create, similar to the 2 groups that Malcolm X created toward the end of his life, the OAAU and the Muslim Mosque Incorporated, right? Now, the OAAU was only for people of African descent, right? The Muslim Mosque Incorporated, that was for Muslims. But there was a common factor, right? The common factor was Malcolm X. Malcolm was the founder of both organizations. So our next step is going to be to take out a greatest common factor from each of these binomials. So hopefully, before you start even trying to factor quadratic trinomials, you already have learned how to factor out the greatest common factor from any type of polynomial, whether it be a binomial, like these two are binomials because they have two terms in them, right? And let me pause for a moment and back up, because somebody might be wondering, well, why is there a plus sign right here if this was a minus sign? Because adding a negative is the same thing as doing subtraction. Remember that. Adding a negative is the same thing as doing subtraction. So saying minus 3x minus 2 is the same thing as saying plus negative 3x minus 2. And when I do this, I like to always have a plus sign in between the two groups. All right? So now, we need to factor out a greatest common factor from this first binomial. So I see a 12 and an 8. So the greatest common factor of 12 and 8 is the number 4. Then I see an x squared and an x. So when you have the same variable, the common factor variable is the variable with the smallest exponent. So this has an invisible 1 exponent. So this is really x to the first power. So that means you out of 12 and 8, the common factor is 4. Out of x squared and x, the common factor is x. So you put the 4 together with the x to get 4x. So that's your common factor, 4x. Right? And then what goes inside the parentheses? You're going to divide each of these terms by 4x. So 12x squared divided by 4x, 12 divided by 4 is 3. X squared divided by x is x. So I got 3x. And then 8x divided by 4x, 8 divided by 4 is 2. X divided by x is 1. So that's 2 times 1. And 2 times 1 is 2. And it's a positive 2. So I'm going to put plus 2. So that part is factored, right? That part is factored for now. And then we keep going, right? Now, over here, this is a little trick. When we do this like factoring by grouping method, which is what this is called, factoring by grouping. When this term is negative, usually one of the cheat codes, basically you can think of it as, is to factor out the negative. Because what's going to happen is the greatest common factor between these two is either a positive 1 or a negative 1, right? Positive 1 or negative 1. We have no other option. But instead of using the positive 1, use the negative 1. And that's something that you do whenever the first term is negative. If this was a positive, then I would just factor out a positive 1. So this is what we're going to do. We're going to do minus 1. And then negative 3x divided by negative 1 is positive 3x. And then negative 2 divided by negative 1 is positive 2. Now look what happened. Both of the binomials match up. Both of the binomials match up. So again, common factor. Omawali, Malcolm X, was the common factor in both of these organizations. 3x plus 2, 3x plus 2. This is how you write the answer, right? You're going to write the final answer like this. Whatever repeats, you write that one time. So this 3x plus 2 repeats. So you write it one time. Now, if you don't get a binomial that repeats, then something is wrong. Either you made a mistake, or maybe this 4-term polynomial, you're not able to factor it by grouping. And you would have to try another method of factoring. Or maybe it's just not factorable. That's also possible. Everything is not factorable. So at any rate, whatever repeats, you write it one time, and then you're going to have another binomial consisting of these two outside terms, this 4x and this negative 1. So you put them together, and in the parentheses, you got 4x minus 1. And that's your final answer right there. Now, let's say we wanted to check our work to make sure that it's correct. Whenever you factor any type of expression, you can always check your work by just multiplying out the factor form, and it should equal the original expression. So if I use the FOIL method, because I like the FOIL method, I'm a fan, right? I do first times first, 3x times 4x. That's 12x squared. Then I do the outer terms. That's 3x times negative 1. That's minus 3x. Then I do the inner terms. That's 2 times 4x. So that's plus 8x. And then I do the last terms. The last one's in the parentheses. So that's going to be positive 2 times negative 1, which is minus 2. And then I collect like terms. My two like terms are negative 3x and positive 8x, leaving me with 12x squared plus 5x minus 2. And isn't that what I started with? So that's proof that this is the correct factored form, and we just used the MalcolmX method to factor a quadratic trinomial. So I hope that made sense. If it didn't make sense, if there were some parts that you were a little lost on, I know there was a lot. I threw a lot at you in this particular example because this is complex stuff, right? So don't feel bad if you don't fully understand it, right? These are the types of problems you got to do over and over again. Like I've been doing this type of stuff for like 30 years, 30 plus years, actually. That's why I could just flow with it. So don't feel bad if you can't just flow with it, but you will be able to as long as you put the work in and practice and do enough problems. Practice, do enough problems. I showed you how to do it, but you actually learn it by actually practicing and doing a whole lot of problems over and over and over and over and over and over again. That's the only way to it. There's no way around it, right? That's just part of the grind. You just got to put that work in, you know? So that being said, please make sure that you're subscribed to the YouTube channel. Make sure you turn on the post notifications so you'll be aware of all the content that we're putting out on a regular basis. Also, check us out on Instagram. Follow us on Instagram at All This Math. And until next time, remember, there's all this math all around you. Peace.